Alright, so we collided two cars of equal mass in this lab. One right here. Wait, how do we mark it? There we go. This one right here, we push off, and then this one here was standing still. And now we're going to examine the momentum of the lab.
Yeah, so the two cars collided here, and then slowed down, and the second one increased its velocity. We graphed the data we got from video analysis, and this is the placement of the second car after the mass here. We saw that it had a slope of 0.576, which means 0.576 meters per second.
See what the velocity was, and also this is the graph for the first car, and so we graphed 2 points. The point right here before the car hits the first car hits the second car, and here the point after the first car hits the second car, and we see that before it hits the car, the velocity is 0.823 meters per second, and then after it hits the first car, it slows down to 0.186 meters per second.
Now we wanted to see if the conservation of momentum worked in our collision, so we decided to do out the mass. So we have m1 v1 plus m2 v2 equals m1 v1 prime plus m2 v2 prime. We know all of the masses are the same because they were of equal mass, so we can cross out all these.
Yeah, okay. Also, we know it's an elastic collision because kinetic energy is conserved, and is that it?
Because it was on a frictionless surface.
Yeah.
Well, as frictionless as we could get, so not that much energy was lost to heat from the friction or any other source. So we decided to input our velocities that we got from our graphical analysis. So we had 0.823 meters per second. That was the velocity of the first car before the collision, plus 0, which was the velocity of the second car before collision, equals 0.56 velocity of first car after collision, plus 0.186 velocity of second car after collision. So we decided to do out the math, and we got that equaled, so 0.823 plus 0 equals 0.823, and the second half of the equation was 0.762. So the conservation was not completely conserved, but we believe that because change in momentum equals force times time, and our plane was not completely frictionless, even though we tried to make it as frictionless as possible. So for the time that friction was acting on the car, the momentum changed, and so the momentum was conserved in the grand scheme of things, but not in our collision. It wasn't a completely elastic collision, which means kinetic energy wasn't completely conserved, but as always, momentum was conserved. Was that 0.839 meters per second was the momentum before, and afterwards it was 0.762. So they don't entirely equal each other, but we are hypothesizing that they don't because some of our energy was actually given off as heat from the friction of the surface, so it wasn't a completely elastic collision.
Yeah, and also when we were plotting in the graphical analysis program, it was on an iPad, so it wasn't the most accurate plot, so we couldn't necessarily plot from the beginning and the end of each phase of the car's velocity, so therefore it might be a little off, but the error is pretty slim, so we're pretty sure that this represents an elastic collision.